Now we will see the aspects on ionization energy and electron gain enthalpy as well as electronegativity. Other two properties, valency and oxides, are functions of these four properties. First, let us recall the concept of ionization energy. Ion means charged particle. Ionization means formation of charged particles. Here we are referring to cationic charge. How the ions are formed? Ions are formed either by removing one electron to the system or by adding one electron to the system. System is originally neutral. If you remove one electron, number of neutrons is higher than number of electrons, so the system becomes positively charged. Whereas if we add one electron to the system becomes negatively charged. So positively charged species are formed during ionization. Negatively charged species are formed during electron gain. So this electron, what is meant by electron gain? Let us illustrate with the example. Let us consider any species A. Species A, if it loses one electron, it becomes A plus electron. It loses one electron. Let us consider another species B. Let it gain one electron. If it gains one electron, it becomes B minus. So you can illustrate with the example of sodium and chlorine. So sodium loses one electron, becomes sodium plus or sodium ion. Whereas chlorine gains one electron, forming chloride anion. So for the cation formation, electrons must be lost. For the anions formation, electrons must be gained. So for the loss of electrons, some energy should always to be spent. That is why it is called ionization energy. Now let us recall the concept of ionization energy. So ionization energy is defined as the energy required to remove the outermost electron from the atom or ion, as the case may be. So it can be applicable for ions as well, because let us consider this: sodium plus, magnesium 2 plus. So for the formation of magnesium 2 plus, we can consider it as two stages. It losing one electron, forming Mg plus. Losing second electron, it forms Mg2 plus. But Na plus will not at all form Na2 plus, because Na plus itself inert gas configuration. So we cannot remove one electron. In the case of magnesium, the second electron can be removed. In the case of aluminium, even the third electron can be removed. Al plus, Al2 plus, Al3 plus. In some, so to a maximum 3 electrons can be removed. Accordingly, so ionization energy, for any removal we have to supply energy. So the definition says that ionization energy is the energy required to remove one electron, but one electron, not the innermost electron, outermost electron, because innermost electron means it is nearest to the nucleus. Nucleus is positively charged. So nucleus is positively charged. So let us consider this sodium. K electron of sodium, M electron of sodium. K shell contains 2 electrons, L shell contains 8 electrons, lastly 1 electron is present in M shell. This is the arrangement for sodium. So if we tell energy required to remove 1 electron from sodium, and actually sodium contains 11 electrons. In the 11 electrons, which electron has to be removed? That is to be noted. Outermost electron can be easily removed, but inner electron cannot be easily removed. That is why the definition says that the energy required to remove the outermost electron from the system, or metallic elemental system or ionic system. For aluminium, outermost first electron, outermost second electron. Magnesium, outermost first electron. Sodium, outermost electron. That's all. First electron or electron, what would be the case. So this is meant by ionization energy. So to condense, ionization energy is the energy required. It is energy requirement. Without the spending of energy, ions cannot be formed. So ionization is not a spontaneous process. That is to be spontaneous means it takes place by itself. So it has to be spent with some energy. So Energy can be supplied either by dissolving or by heating, whatever be the method. Some or one or other method, energy has to be supplied. That is to be noted. So sodium loses electron. Sodium is getting ionized. The energy consumed is called ionization energy. So depending upon the types, which electron is to be removed, ionization energy is of types. First ionization energy, second ionization energy, and third ionization energy. There are three types of ionization energy. First ionization energy is the energy required to remove one electron from the neutral atom, that is outermost electron from the neutral atom. Whereas second ionization energy is the energy required to remove the second outermost electron. If you remove one electron, the system becomes positively charged. Electrons are negatively charged. So there is a better interaction between positive charge and negative charge. Already we have seen the example. One theft means the second theft cannot immediately happen. The people will be quite alert. Second electron, it is somewhat difficult. That is quite difficult with the case of sodium. You cannot remove the second electron from sodium. Magnesium, 2 electrons can be removed, Mg2+. Aluminium, 3 electrons can be removed. So it is patient up to third theft, we can tell. But so carbon, you cannot remove 4 electrons or you cannot add 4 electrons, because carbon atomic number is 6. So inner shell contains 2 electrons, outer shell contains 4 electrons. Octet configuration means it has to add 4. So or it has to lose 4 to get helium configuration. But losing 4 electrons or gaining 4 electrons is a quite tough task, because if it becomes 1 electron, it becomes positively charged. Second electron cannot be removed. Third electron can never be removed. Fourth electron, no question. So that is why it goes for sharing. So ionization energy only up to third ionization energy. But oxidation state can be any number. It has nothing to do. For it, what is meant by oxidation state? Already we have studied in redox systems. What is the oxidation state of manganese in potassium permanganate? We have studied. So potassium is assigned +1. Oxygen is assigned -2. We have done this sum +1. Manganese oxidation state we don't know, X. If we assume totally the molecule is electrically neutral, that is no charge, net charge. The charge on the system is 0. So 1 plus X minus 8 equal to 0, or X equal to 7. That is X equal to +7. X equal to +7 means oxidation state is +7. So it may appear as though manganese has lost 7 electrons. It is not the case. So oxidation state has to be carefully distinguished from the number of electrons lost. Carbonium ion is there. It is temporary intermediate, but it cannot lose 1 electron. Carbon ion is the temporary intermediate. For some electronegativity phenomenon, it can meddle with electrons, that's all. But it cannot permanently take 1 electron, or it cannot permanently lose 1 electron. So ionization energy, there are 3 types of ionization energy. Next, what is the variation of ionization energy along the period as well as group? It is similar to, remember, similar to atomic radius. Ionization energy decreases along the group, whereas increases along the period. Trend is opposite, but it has in any property along the period one trend will be there. What is the trend? Increasing or decreasing. So we have seen that size increases along the group and decreases along the period. But ionization energy along the group it decreases. Along the period it increases. You will see why it is so. So lithium, let us compare first group elements, and lithium, sodium, potassium, rubidium, cesium and francium. The electronic configurations are 2s1, 3s1, 4s1, 5s1, 6s1 and 7s1. So the electronic configurations are 1s1 to 7s1. 1s1, 2s1, 3s1, 4s1, 5s1 and 6s1. So if all they will form positive charge. So For the formation of lithium ion from lithium, for the formation of lithium ion from lithium, the 2s electron has to be removed. For the formation of sodium ion from sodium, 3s electron has to be removed. 4s electron has to be removed for potassium, 5s for rubidium, 6s electron has to be removed from cesium, and francium has to lose 7s electron. All are s electrons, but for lithium 2s electron. So second shell is nearest compared to seventh shell. So from the nucleus, second shell is the nearest and seventh shell is farthest apart from the nucleus compared to the second shell. Or so the distance is very high means we have studied that force is inversely proportional to square of the distance between them. So force is very low. So attractive force is very low for seventh shell. Attractive force is very high for second shell. So the attractive force is very high. Nucleus is positively charged. Electrons are negatively charged. Attractive force is very high for inner shells means it is very difficult to remove electron from the inner shell. But it is easy to remove the electrons from the outer shell. So removal process easy means less energy is spent. Removal process is difficult means more energy is spent. That is why along the group the ionization energy decreases. Once again to condense, ionization energy decreases along a group because the outermost shell is farthest from the nucleus. 7s shell is farthest compared to 2s shell. Whereas along the period ionization energy increases. That we can illustrate in this group. Beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. All are in the one period. Here from left to right, increase in atomic number. Lithium, beryllium 4, 5, 6, 7, 8, 9, 10. So all are p block elements. 2p1, 2p2, 2p3, 2p4 like that. So 2s1, 2s2, 2p1, 2p2 all are only in the p shells. All are only in the p shells. So this p shells means the electrons are going to the same shell, but the 5 positive charge, 6 positive charge, 7 positive charge, 8 positive charge, 9 positive charge and 10 positive charge. All are only outermost electron. So outermost electron is under the control of 5 positive charges. Outermost electron is under the control of 6 positive charge. Outermost electron is under the control of only 1 electron, but it is under the control of 10 positive charges. So 10 opposite charges will have better attraction. So it is very difficult to remove electron from the neon. So from left to right, more energy has to be supplied because more attractive force. So F is proportional to Q1 Q2 by R square. Here Q1 is the outermost electronic charge, that is constant. Q2 is the protonic charge. Protonic charge increases, directly increases. So more force increases means more energy has to be supplied. That is why ionization energy increases along the period. So in general, ionization energy increases along the period, decreases along the group. Whenever we tell any rule, it will follow some anomaly. There is some deviation. Why there is some deviation? So they will compare between nitrogen and the oxygen. Nitrogen, the same. Nitrogen, oxygen, fluorine and neon. Beryllium, boron, carbon. So it is decreasing. Nitrogen and oxygen, if they compare, the ionization of nitrogen is typical in nature because nitrogen electronic configuration is 2s2, 2p3. So 1s2, 2s2, 2p3. So the atomic number of nitrogen is 7. 1s2, 2s2, 2p3. P3 is the half filled configuration. P6 is the total capacity. P3 is the half-filled configuration. Half-filled configuration means the system is highly stable. You cannot add electron or it cannot remove one electron. In general terms, if the house is quite compact, any excess person or deficit person will lead to chaotic situation. Here also, it will not accept easily another electron. You cannot remove one electron easily. That is why nitrogen cannot form N plus or N minus. It is very difficult. So, lithium plus is possible. Beryllium 2 plus is possible. Boron onwards decreases. Now, carbon covalent. Nitrogen, it will not form N plus or N minus, but oxidation states are there for plus and minus, similar to manganese we have discussed. That is to be noted. Nitrogen is highly stable because of half-filled configuration. Maximum stability exists with helium, neon, argon, krypton, xenon and radon. These are called inert gases because helium is inert gas. It is quite compact. You cannot remove one electron. Octet configuration is stable, neon. So, they have maximum ionization energy. Ionization energy increases along the period. Along the period, lastmost group is nothing but noble gas or inert gas group. Their ionization energy is maximum. Ionization energy is lowest for alkali metals, first group metals, hydrogen, lithium, sodium, excepting hydrogen. Hydrogen is a non-metal. Lithium, sodium, potassium, rubidium, cesium, francium, they can form easily there. So, this is the trend above. So, lastly, next, what are the factors influencing how we justify these variations? Factors influencing the ionization energy. First one, nuclear charge. Second one, screening effect. Third one, size. Three important factors which influence the ionization energy, variation of ionization. As the size increases, outermost electron goes farthest from the nucleus. It has least control over the nucleus. So, ionization energy is inversely related to size. As the size increases, ionization energy decreases. Screening effect means inner electrons screen the attractive force between the nucleus and outermost electron. So, outermost electron is controlled over the nucleus. So, higher screening effect, lower ionization energy. Higher screening effect, lower ionization energy. But higher nuclear charge means more force, positive force. So, very difficult to remove one electron. So, nuclear charge is directly related to ionization energy, whereas the other two are inversely related to ionization energy. And half-filled configuration, the system provides extra stability. That is to be noted. In the covalent species temporary intermediates C plus, C minus, we tell in this character. Lastly, there is one phenomenon called S character. What is meant by S character? In the hybridization, we have studied that hybridization is the phenomenon of mixing up of atomic orbitals to give rise to molecular orbitals. Important types of hybridization: sp, sp2, sp3, like that, sp3d. So, in the chemical bonding and molecular structure, valential electron pair repulsion theory, we have studied about these types of hybridization. What is meant by S character? All these letters to refer to individual orbitals. One S orbital and one p orbital overlaps in sp. sp2, one S orbital and two p orbitals are overlapping or mixing. In sp3 hybridization, only one S orbital overlaps with three p orbitals, like that. Now, let us compare what is in the S character, percentage of S orbital in the hybridization. Here number of S orbital is 1, total number of orbital is 1 plus 1, 2. So, S character is 1 by 2 or 50%. In the case of sp2, number of S orbital is 1, but total orbital is 1 plus 2, that is 3, 33%. sp3 it is 25%, 1 by 1 plus 3. So 25%. Here it is still more 20%. 1 by 1 plus 3 plus 1. 1 by 5. 20%. So from left, so these are the different methods of hybridization. sp, sp2, sp. Here denominator denotes total number of orbitals. Denominator denotes total number of orbitals, whereas the numerator denotes only the number of s orbital. So this is called S character. Hybridization all involve s orbital, but proportion of s orbital is very low in one case. Proportion of s orbital is very high in other case. So S character is more, means S electrons, s orbital electrons cannot be easily removed. Cannot be easily removed. What is meant by S electron? Everywhere in the periodic table, from lithium we will start. Ionization energy is lowest for first group metals, first group metals, not for hydrogen. Hydrogen is the first group element. Hydrogen configuration is 1s1. So 2s1, 3s1, other electrons are easily removed, but 1s electron is very difficult to be removed because 1s is the nearest to the nucleus. Nearest to the nucleus. Nearest to the nucleus means nucleus will have maximum attractive force over the one electron. So it is very difficult to be removed. So higher the S character, more is the ionization energy. So ionization energy is influenced by these factors. Now we will see the next important ionization concept. It is not formation of negative ion. Ionization refers to the formation of positive ions by the loss of electrons. So electrons can also be gained by systems. Such property is called electron gain enthalpy. Electron gain enthalpy. Enthalpy or energy both mean the same in thermodynamic terms. So ionization energy or ionization enthalpy both mean the same. Energy required to remove the one electron from neutral species is called ionization energy. It is also called ionization enthalpy. Then what is the difference between why we are using synonymously these two terms? Energy is a vector quantity. This vector quantity is assigned along with the sign. Enthalpy. Enthalpy can be negative or positive or zero, whatever be the case. But energy, numerical value, it compares. So whether it releases or absorbs, what is the energy involved? That is to be noted. So electron gain enthalpy is defined as energy released when one electron is added to a species. It is not for metals, we can do it for any other elements. Chlorine is the best example. Chlorine, electron, it forms chloride. So during the formation of chloride from elemental chlorine, it releases energy. But during the formation of sodium ion from sodium, we have to supply energy. Sodium to sodium ion conversion, energy has to be supplied to the system. But chlorine to chloride ion conversion, the system releases energy. If it releases energy, it goes to the lower energy state. If it goes to the lower energy state, it becomes more stable. So that is why even in common chlorine, we tell chlorine water, chlorine water. What is chlorine water? Chlorine combined with water. In this so chlorine combined with water, immediately it will form HCl and HOCl. HCl will be split as H plus Cl minus. HOCl will be split as H plus OCl minus, or it will liberate HCl and O, whatever be the case. So in any case, Cl minus is the most stable. Cl gains one electron to form. So in this process, so electron is gained by chlorine and energy is released by chlorine. So this is called electron gain enthalpy. So electron gain enthalpy is required to be high. If high energy is released, system goes to the low energy state easily. If it goes to the lower energy state easily, it becomes stable. So electron gain enthalpy. Here also we have two types. First electron gain enthalpy, second electron gain enthalpy. So first electron gain enthalpy, first electron gain enthalpy value is negative, means that it releases energy. Second electron gain enthalpy value is positive, means that it requires energy. It requires energy. Let us illustrate lastly with the example of chlorine and oxygen. Chlorine, with the addition of one electron, it forms chloride. Whereas oxygen, with one electron, it forms one type of oxide. It also adds one electron to form oxide anion. There are two types. So first process releases energy, electron gain enthalpy is negative, but second process consumes, that is electron gain enthalpy is positive. So electron gain enthalpy can be negative or positive. If the energy is released, it is called negative. If the energy is absorbed, it is positive. Here also, the inert gases, they will neither release energy, they will not form the anions easily. So even xenon fluoride is formed, means xenon cation is formed. Xenon anion is not formed. So it is very difficult to form the anions. Anions means negatively charged species for the, already they are packed with the electrons. They are coming at the last. They have the maximum number of electrons. Octet configuration has been achieved. If the octet configuration is achieved, one more electron cannot be easily going into the system. So electron gain enthalpy, we cannot strictly adapt this for the period or group variation. In general, electron gain enthalpy decreases along the group and increases along the period, because chlorine, halogens or chlorine is electron affinity is maximum from left to right electron. So this electron gain enthalpy or electron affinity both mean the same. Electron gain enthalpy or electron affinity both mean the same. Affinity towards the electron increases along the period and decreases along the group. So this is meant about the electron gain enthalpy or electron affinity. Now lastly we can see about the concept of electronegativity, Pauling's terms, its variation and its influence on other properties. Due course.